The evolution of electricity began in the 17th century. Back in 1752, Benjamin Franklin demonstrated that lightning was a form of electricity with a kite experiment. In September 1882, a house in America was powered by hydroelectricity. The station that powered the home used the direct current, DC, system developed by Thomas Edison. After Edison's experiment, electric power in homes became mainstream. The standard form of electricity used in the United States was the DC system. In the late 1800s, DC could not be easily converted to high voltages. As a result, Edison proposed a small, local power plant that would power homes. With this system, power plants needed to be located within 1 mile of their end users. The limitation of the DC system made it challenging to distribute power in rural areas. Nikola Tesla, a student of Edison, believed that AC was a better option for use in the home. This is because power could be converted to higher or lower voltages much more easily and efficiently with transformers. It was cheaper to distribute and supply power to larger areas with an AC system. This is why eventually, AC became the new standard for electricity in the US in the late 1800s. In the earliest days of home electrification, electricity was often carried place to place by bare copper wires with minimal cotton insulation. Sockets, switch handles, and fuse blocks were made of wood. From about 1890 to 1910, knob and tube wiring was used for electric installation. Knob and tube wiring is open electric wiring work. Wires are supported on knobs and encased in tubes where they pass through beams or partitions. In this early setup, hot wires and neutral wires were run separately. They were insulated using rubberized cloth, which degraded over time. From the 1920s to the 1940s, insulated wires were enclosed in rigid metal tubes. Electrical cable encased in metal sheathing was introduced in the earlier 1900s. These flexible armored cables were enclosed in rigid metal tubes. This offered some protection from wire damage. During these years, the potential for danger was much higher than today because the equipment wasn't grounded. If a hot wire becomes damaged, the electrical current escapes the wiring pathways. After 1965, equipment was grounded to direct electrical current back into the ground to create a safer environment. In the early 1900s, before electricity, we had to accomplish everyday tasks manually. Occasionally, we used to run gasoline engines to power pumps, washing machines, or other equipment. The other shortfalls of living without electricity were that gas and kerosene lanterns were the primary source of light after dark. Wood was the primary source of heat to keep a house warm and to cook a family's food. With the invention of electricity, all these shortfalls were eliminated. In the 20th century, most Americans continued to illuminate their homes using gas lamps. In 1925, only half of all American homes had electrical power. With FDR's Rural Electrification Act of 1936, by 1945, 85% of American homes were powered by electricity, with virtually all homes having electricity by 1960. As we settle into the 21st century, electricity continues to evolve. When it comes to our power sources, coal, petroleum, and natural gas have been our primary sources of electrical production since the early 20th century. According to the Center for Climate and Energy Solutions, CCES, renewable energy is the fastest growing source of electricity in the United States. It has increased up to 67% from 2000 to 2016. It includes wind, solar, and hydroelectric power. As technology improves over the next few decades, a transition to renewable power sources as our primary electricity producers is likely. In addition, the direct current has been making a comeback. LEDs and computers use DC. Engineers have learned that DC may be more efficient than AC when transmitting millions of volts over large regions. New DC transformers can convert low voltages to very high ones. Increased use of electric cars, which operate on DC power, will also push the demand for DC. Modern electrical systems are more efficient than systems used in the past. Most modern homes also have circuit breakers that immediately shut off power if they sense an overload, providing additional safeguards. Modern electrical systems like variable speed drives, VSDs, and variable frequency drives, VFDs, allow us to control the speed of a motor. This allows us to maintain the speed of a motor according to the load requirement. This can save energy up to 35 to 60%. Modern electrical systems have longer equipment life and reduced maintenance. For example, in most old transformers, losses occur through heat or vibration from the core. New high-efficiency transformers minimize these losses. The limitation of the DC system made it challenging to distribute power in rural areas. This is why, eventually, AC became the new standard for electricity in the US in the late 1800s. After 1965, wires were grounded to direct stray electrical currents back into the ground to create a safer environments. According to the Center for Climate and Energy Solutions, renewable energy is the fastest growing source of electricity in the United States. Modern electrical systems are more efficient than systems used in the past. An electrical system consists of all of the elements needed to distribute electrical power. It includes overhead and underground lines, poles, transformers, and other equipment. An electrical system is required to run pumps, compressors, manufacturing systems, refrigeration systems, and motor control panels. We need to ensure that electrical systems are working correctly. If there is any fault in an electrical system, we need to consult an electrician. An electrician is a high-skilled tradesperson that installs and repairs wiring and components of any electrical system. The duties of electricians are as follows: diagnose electrical problems using diagrams or blueprints, install and repair electrical systems, inspect, troubleshoot, and conduct tests, and pinpoint problems using a range of testing devices. The duties of electricians are as follows: safely use various hand and power tools, and plan the layout and installation of electrical wiring, equipment, and fixtures. The duties of electricians are as follows: comply with all safety standards and regulations of the National Electrical Code, and supervise and train others in installation and repair work. To work as an electrician, one must have the following skills: hand-eye coordination, color vision, physical fitness and a good sense of balance, troubleshooting and analytical skills, and ability to work in a team. An electrician must be able to identify wires by color, so normal color vision is critical. They may be on their feet all day and work at high elevations. This requires them to have good balance to avoid injury. An electrician will have to lift objects that weigh up to 50 pounds. This is why an electrician should have physical fitness. Many electricians work in teams with limited supervision. That's why they should be able to work in a team. This will help them figure out the best solutions for a wide variety of problems. Electricians might work indoors in residential and commercial buildings or outdoors on construction sites. They work in cramped spaces and spend a lot of time standing or kneeling. Electricians are prone to minor injuries, such as burns, shocks, and falls. We should always wear protective clothing and personal protective equipment while working with electricity. Electricians typically work full-time and may work overtime hours as necessary. Self-employed electricians might opt to work longer hours in the interest of maintaining and growing their businesses. An electrical system consists of all of the elements needed to distribute electrical power. If there is any fault in an electrical system, we need to consult an electrician. An electrician is a high-skilled tradesperson that installs and repairs wiring and components in any electrical system. To work as an electrician, one must have the following skills: eye-hand coordination, color vision, physical fitness and a good sense of balance, troubleshooting and analytical skills, and ability to work on a team. In the United States, electricians are divided into different categories. These categories are based on type of work an electrician does, education and certification that an electrician has completed, and specializations that an electrician has done. Let's discuss each of them in detail. The different types of electrician based on the scope of work they do are linemen, also called outside electricians, and wireman, also called inside electricians. Let's go over each of them. Linemen, or outside electricians, work outdoors installing electric utility transmission and distribution systems at higher voltages. They are responsible for making sure electrical wiring is working properly. This will ensure that power is being correctly distributed from generation facilities to end users. High-voltage linemen may work on high-tension voltage lines positioned hundreds of feet above the ground. That's why an outside lineman must receive extensive safety training, including climbing training. Wiremen, or inside electricians, work with the lower voltages found inside buildings and structures. Wiremen install, maintain, and repair electrical systems that provide power to residential, commercial, and industrial buildings. Residential systems, such as solar panel installation, would fall under this category. The types of electricians based on education and certifications are apprentice, journeyman electrician, and master electrician. Let's go over each of them. The first level of education for an electrician is the apprenticeship program. Electricians do not need a formal education to begin an apprenticeship, but they must pass the General Educational Development (GED) exam. The GED test provides certification that the test taker has high school level academic skills. An apprentice program allows electricians to begin work immediately as electrician assistants under supervision. They will receive the hands-on experience required to advance their career. Upon completing an apprentice program, individuals will be eligible to take a test to become journeyman electricians. This title implies that the individual is licensed and able to work without supervision. Master electrician is the highest level of electrical certification. Master electricians work on the most complex commercial and industrial projects. They have the experience to train journeyman electricians to do the same. A licensed electrician can also select specific areas of specialization. Some popular specialty areas are industrial electricians, commercial electricians, residential electricians, maintenance electricians, and installation electricians. Let's discuss each of them. A residential electrician is responsible for maintaining, troubleshooting, and upgrading electrical systems within homes. A residential electrician will work across several residential settings, including houses and apartments. They may work independently or as an electrical contractor. Commercial electricians perform similar duties to the residential electrician but work in commercial buildings. A commercial electrician may also be asked to install security systems, electronic systems, fiber optic systems, and heating and cooling systems fit for an office. We can find an industrial electrician working on large-scale projects across industrial facilities. These include factories, manufacturing facilities, and power plants. An industrial electrician works with large machinery and computer systems used to facilitate the industrial process. The electrical work needed in these buildings will exceed those in commercial or residential settings. Installation electricians work with electrical system installation in new buildings. This includes setting up all electrical equipment and wiring for lighting, heating, cooling, and security systems. They may split their time between residential, commercial, and industrial projects. Maintenance electricians must install, maintain and monitor electrical systems operating in plants and factories. They are responsible for making routine inspections to check on current equipment. If operating conditions are not up to standard, they must conduct timely repairs or replace the equipment. According to the U.S. Bureau of Labor Statistics, electricians had a median annual salary of $55,190 in 2018. This included a mean hourly wage of $28.50. The best paid 25% made $472,780, while the lowest paid 25% made $41,260. The best paying metropolitan areas in the U.S. are San Francisco, New York, Chicago, and San Jose. Industries with the highest wages for electricians are natural gas and real estate. The median annual salaries of similar trades is as follows: drafter, $55,550, carpenter, $46,590, plumber, $56,330. These trades may require more education, and are also subject to different licensing requirements. Electrical work is a growing trade. According to the U.S. Bureau of Labor Statistics, electrician jobs are expected to grow by 8.4% from 2019 to 2029. This is more than double the 3.7% growth rate projected for all occupations. The increase in demand is driven by electronic devices and building components that rely on electricity. From 2021 to 2022 alone, total electricity consumption in the U.S. is expected to grow by 1.4%. People are using more electricity than before, and more electricians are needed to install and maintain these electrical systems. This is the reason there is high demand for electricians. The electrician shortage is the result of a mismatch between supply and demand. There are three main causes behind the electrician shortage. These include: experienced electricians are retiring, not enough new electricians are entering the industry, and demand for electricians is increasing. In the United States, electricians are categorized based on type of work an electrician does, education and certification that an electrician has completed, and a specialization that an electrician has done. According to the U.S. Bureau of Labor Statistics, electricians had a median annual salary of $55,190 in 2018. The electrician shortage is the result of a mismatch between supply and demand. This is because experienced electricians are retiring, not enough new electricians are entering the industry, and demand for electricians is increasing. The National Fire Protection Association, NFPA, is an international organization for eliminating death, injury, property, and economic loss due to fires. Electrical hazards are a major cause of fire. NFPA is responsible for 380 codes and standards designed to minimize the risk and effects of fire. The NFPA 70E is a standard for electrical safety in the workplace. It provides practical safeguarding of employees during activities such as installing electric equipment, maintaining electric equipment, and demolishing electric conductors and electric equipment. The National Electrical Code, NEC, is a set of regularly updated standards for the safe installation of electric wiring in the United States. All electricians are expected to abide by NEC standards while dealing with any electrical equipment and wiring. The NEC is approved as an American national standard by the American National Standards Institute, ANSI. It's updated once every 3 years. The Occupational Safety and Health Administration, OSHA, ensures workers safe and healthy working conditions by setting and enforcing standards. OSHA also provides training, education, and assistance to electricians through its programs. The electrical safety requirements by OSHA can be found in two separate subparts as follows: Part 1910, Subpart S, and Part 1926, Subpart K. Subpart S addresses electrical safety requirements for the electrical industry. Subpart K focuses on electrical safety in construction. The organizations that provide service for electricians are International Electrical Testing Association, NETA, and Institute of Electrical and Electronics Engineers, IEEE. The International Electrical Testing Association was formerly known as the National Electrical Testing Association, NETA. NETA's goal is to establish uniform testing procedures for electrical equipment and standardized procedures to test technicians' knowledge. The Institute of Electrical and Electronics Engineers, IEEE, is the world's largest professional association dedicated to advancing technological innovation. IEEE is a leading standards development organization that has developed over 900 industry standards in various disciplines, including electric power and energy. A licensed electrician works with electrical equipment, including electrical panels, wires, and industrial systems. Licensed electricians complete state-approved licensing programs and exams to work in their respective states. A certified electrician is a state-licensed electrician who seeks additional certifications to work in specific industries or businesses. Electricians can obtain certifications in areas like instrumentation, electrical safety, and solar. Licenses and certifications are not the same. Electricians must have a license to perform work in their area legally. An electrician certification is entirely optional and demonstrates an electrician's continuing education and subject mastery. An organization distributes a certificate to indicate an electrician has completed specific educational requirements. Certificates indicate that an electrician has demonstrated a certain level of knowledge. Certificates are helpful marketing tools for electricians. For example, when electricians seek employment at an electrical company, certificates can make their resume stand out. When master electricians decide to start their own business, an impressive list of certificates can attract potential customers. An electrician can apply for the following licenses: Journeyman Electrician License, Master Electrician License, and Electrical Contractor License. Let's look at each of them. For a journeyman license, we have to complete the required apprenticeship program. After completing the apprenticeship, we need to pass the electrical journeyman exam. A master electrician license is achieved after 2 years as a journeyman electrician and passing the master electrician exam. The electrical contractor license is an optional business license reserved for master electricians that operate an electrical contracting business. There are numerous certifications available for electricians. These certifications are in the following domains: Electrical Training Alliance certifications, Electrical Safety certifications, and Renewable Energy certifications. To summarize, the process for becoming a professional electrician is as follows: earn a high school diploma or pass the General Educational Development (GED) test, apply for an apprenticeship, and get licensed or certified in your state. The cost of becoming an electrician varies enormously. Apprenticeship fees can run between about $400 and $1,000 per year. However, many apprentices have their tuition paid by their employers. For a license, candidates should file an application for licensure with the State Board of Electrical Examiners. Application requirements vary by state and license type, but common requirements include proof of experience, application fee, and certificate of completion of an apprenticeship. Once the board approves the license application, applicants should follow board instructions on scheduling the relevant exam. This license typically expires annually. Individuals who fail to renew their license may face penalty, including license suspension. The penalty for unlicensed electrical contracting work will start at $1,000 for a first offense. The second and third offenses will carry penalties of $2,000 and $3,000, respectively. After the third time, offenders can expect to pay $10,000. The organizations that provide service for electricians are National Fire Protection Association, NFPA, Occupational Safety and Health Administration, OSHA, International Electrical Testing Association, NETA, and Institute of Electrical and Electronics Engineers, IEEE. The process for becoming a professional plumber is as follows: earn a high school diploma or pass General Educational Development (GED) test, apply for an apprenticeship, and get licensed or certified in your state.